Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, let us discuss today definitions and terminology related to file handling concepts in C language. Now, why we should use a file? So, when we have bulk amount of data or large amount of data to store and retrieve, then it is convenient to go for a file. Now, whenever you want to use a file in C language, then you should know what are the basic operations you should do on a file. There are only three basic operations. One is called either creating a new file or opening an existing file. Second operation is called do the read and write operation on the file. Either you have to read some content from the file or write some content to the file. And the third operation is called once our work is over, then we should close the file. Now, for creation of the file, we should use the fopen function. And if you are creating for the first time, then use the mode W or W+. Similarly, if you are opening a file which already having some contents, then open the file in append mode, A or A+ mode. Similarly, whenever you are opening an existing file to read some content, then go for fopen function. If you want to do some reading from the file already contains some content or records, then use fscan function or fgetstring function. Similarly, whenever you want to write some content to the file, then use fprint function or fputs function. Now, if you want to do any random accessing to the file, that means if you want to move to a specific location in the file, then use fseek function, rewind function, and ftell function. These are the very beautiful functions used in C language for doing the random positioning in the file. Now, once your work is over, you should close the file using fclose function. Now, after understanding the basic file operations, let us understand the file opening modes. The files can be of two types. One is called text file, another one is called binary file. So, text file and binary file. Now, if you want to deal with a text file, then what are the modes you should use? There are three basic modes. One is called read mode, write mode, and append mode. These are the three basic modes for a text file. If you are opening a file in read mode, then the file pointer always points to the first character in that file. And if the file could not be opened due to some reasons, then the fopen function returns null. Similarly, in the write mode, a new file will be created and ready for writing. If the file could not be opened due to some reason, then fopen function returns null for the write mode also. Then the third mode is called append mode. In the append mode, one existing file with some content, you can open it and you will find that the file pointer will be waiting at the end of the file, from where you can add some new content to the file. Now, these are the three modes for text file. Similarly, R, W, and A are the three modes for text file. If you are dealing with binary files, only a small change that you have to do. You have to write down the binary mode RB, WB, or AB. So you can see over here WB, RB, and AB are the three modes used in the similar manner for doing reading, writing, and appending some contents to the file. Only the mode B indicates that you are dealing with a binary file. Similarly, there are some advanced modes called R+, W+, and A+ for the text file, R+, W+, and A+. If you are dealing with binary file, then it becomes RB+, WB+, and AB+. So you can see over here. So if you want to do more than one operation simultaneously, then you can use this advanced modes. If it is R+ mode, then if the file is successfully opened in R+ mode, then first you can do reading, then writing. Similarly, if you are using W+ mode, then first you can do writing, then reading. If you are using append plus mode, A+ mode, then first you can append some content to the file and then you can do reading. Similarly, if you are dealing with binary files, then add the character B to the end of the mode, that is RB plus, WB plus and AB plus. Only the functionalities are similar to R plus, W plus and A plus. Now, let us discuss deeply into how to do accessing or how to access the content of the file in C language. So, for accessing the content of the file, you can use either sequential access or random access method. So, when a file need to be accessed or the records need to be accessed one after the other in a sequential or linear order, then we'll go for sequential access. But in most of the applications, sequential access will not be suitable and we need to access the file contents randomly. So, if you want to read or access the records of the file somewhere in the middle or somewhere from the random position, then sequential access is not preferable and we should go for random access. So, how to do random accessing? For that, in C language, there are three functions. One is called fseek, ftell and rewind. Now, let us discuss more about these three functions. Now, first function is called fseek function. This function is used to set the file pointer at a desired location or at a specified byte. This function takes three arguments. One is called the file pointer, second one is called the displacement and third one is called the origin. So, file pointer is nothing but the address of the file where you want to keep the file pointer at a particular byte. Displacement denotes the number of bytes which you want to skip, you want to go or skip either to backward or forward from the specified position or from the current location. Normally, displacement is written as a long integer which can be either positive or negative. Now, the third one is called the origin, that from where you want to take the file pointer and keep it in a specified location. So, the origin is nothing but the position relative to which the displacement should take place. So, it takes one of the three values. So, in the origin, you can either write seek underscore set or its equivalent integer value is 0, which indicates that you are at the beginning of the file. Similarly, seek underscore current, that is the value is 1, which indicates that you are at the current position. That is neither beginning nor end. Similarly, seek underscore end, the equivalent integer is 2, which indicates that now you are at the end of the file. So, using this three, your origin values, you can specify that where you want to take the file pointer or up to at which byte you want to set the file pointer. Now, the next function is called ftell. This function returns the current position of the file pointer. So, the current position of the file pointer is always counted with respect to the beginning of the file. So, this particular function takes one argument called the file pointer fp and it returns a long integer which indicates that the current position of the file pointer. Now, let us understand one example related to fseek and ftell. For example, I have opened a file here in read mode. That means the file already contains some content and I am opening the file in read mode. Now, how will you check the file gets opened successfully or not? For that, you have to check the value of fp. If fp is equal to null, that means there is error in opening the file. Now, after opening the file pointer is always positioned at the 0th character that is at the beginning of the file. So, you can check that the current file pointer position, you will always find that it is at 0th character. Now, I want to move my file pointer to the 10th character, so which is a forward direction. So, I can do that by writing fseek from the current file pointer fseek of fp. fp contains, now fp is positioned at the 0th character. Now move forward. So that's why writing a positive displacement, and if you can, it is a long integer, so you can also write plus 10l, and from where? From the origin you can write as 0. Otherwise, you can also write like this. So fp, comma, plus 10l, that is seek underscore set. So both means the same over here. That means from the beginning of the file, you move your current file pointer position to the 10th byte. After that, you can again check the file pointer position after displacement. You can check that it is at 10th location. Okay. Similarly, if you want to move how many bytes, the displacement can also be written like this. fseek, fp, size of the file pointer from 2. 2 means you are talking about the end of the file. Okay. Similarly, you can check after that what is the current file pointer position. The next function is called rewind function. This function is used to move the file pointer to the beginning of the file. Now, this function is useful when you want to quickly take the file pointer from end to the beginning of the file. And rewind function only takes one argument, that is the address of the file. So you just give the file pointer address, it will move your file pointer to the beginning. Now, let us understand one example related to rewind. So, first of all, we are opening a file which is in read mode, and then we are checking that the file gets opened successfully or not by writing fp is equal to null or a valid address. Now, what is the current position of the file pointer? It is always at the 0th character. Okay. Now, we want to move to the end of the file. So, you can check the position by writing fseek. You can do fp, 0, 2. That means it will go directly to the end of the file. Now, check the file pointer position. Now, it is showing 55, which is nothing but the end of the file in this file.txt. Now you are at the end of the file. If you want to take the file pointer again to the beginning, then write rewind of fp. Directly file pointer will now point to the first character or 0th character in the file. So, you can check that using ftell, and you will see that the position of the file pointer is now at the beginning. Now, let us understand a number of questions related to file handling. So, which of the following is true about file star fp? So, if you are writing like this, then which is the appropriate option? So, what are the options? File is a keyword in C language for representing files, and fp is a variable of file type. Second option is file is a structure, and fp is a pointer to the structure of file type. Third option is file is a string, and file is a buffered string. Out of this 4 options, which is the appropriate option? The appropriate option is the second one. File is a structure, and fp is a pointer to the structure of file type. Because as soon as you create a file, this built-in structure, file is a built-in structure which records a number of information related to the file. That is, at what time the file is opened, in which mode it is opened, who is the creator of file, what is the last operation we have done. A number of information related to file automatically gets stored in the file structure. Now, always if you want to access the file, then fp is a pointer to the structure of file type. So, the answer B is the correct one. Next question is, when fopen is not able to open a file, then what value it returns? Whether it returns end of the file, or null, or runtime error, or compiler dependent. So, when fopen is not able to open a file due to some reasons, then it always returns null. Then the third question related to getC function. getC function returns end of the file when first option is end of the file is reached, or when getC fails to read a character, or both A and B and none of the above. So, getC function will return null when end of the file is reached, and also when getC fails to read a character. So, the answer for this question is C, that both A and B options are correct. Let us go for the fourth question. In the fourth question we have, when we are using fopen function, the open mode WX if you are writing, the WX mode is sometimes preferred over W because of what reasons? So there are two reasons given. One is called the use of WX is more efficient. The second reason is if W is used, then old contents of the file are erased and a new empty file is created. When WX is used, then fopen returns null if the file already exists. So, out of these two options, which is correct? The options are only one or only two or both 1 and 2 or neither 1 and 2. So, the correct option or the correct answer for this is the B option, which is only 2. Because why it is preferred? Because if you are using simply W in the mode, then always the old file contents are erased and a new file is created. But when you are using WX, then fopen returns null if the file already exists. So the answer is the second option, that is B. Next question is regarding fseek function. Fseek function should be preferred over rewind mainly because of what? First option is rewind doesn't work for empty files. Then rewind may fail for large files. Then in rewind, there is no way to check if the operation is completed successfully or all the above. Now, regarding rewind function blindly takes the file pointer to the beginning of the file, but it never checks whether the file operations are completed successfully or not. So, the fseek function should be preferred over rewind due to the option C. So, in option C, it has told that there is no way to check if the operation is completed successfully. So, that's why fseek should be preferred over rewind. Next question is select a function which is used to write a string to a file. So, which function is used to write a string to the file? Options are pits, fputc, puts, fputs and fgets. So, out of these four options, the first function is this name is not a valid function name. Putc is used for your put a character to the file, that is single character, but it is asked that to write a string to a file. So the correct option is C, that is fputs. Fputs is a function which will put a string to a file. Next question is which of the following is correct syntax for opening a file? So if you want to open a file, then there are two ways. One is called, you can use the low level disk IO functions or you can use the library functions. Normally, library functions are preferred over the low level disk IO functions. Now, if you are using the library function, then fopen function should be used. And fopen function takes two arguments. One is called the name of the file and the second one is called the mode in which you have to open the file. So, the first option is the correct one, fopen constant file name and then constant character mode. Okay, and B and D are having only one argument, so it is not correct. But the option C will be correct if the question is related to low level disk IO. But if nothing is mentioned, then we will always talk about the library functions related to file opening, which is fopen. So the option A is correct. Now, next question is related to fflush. So fflush is a beautiful function which is used to clear any congestion if it is there in either input stream or output stream. So whenever you are writing fopen of null, then it flushes what? Whether it is flushing input stream contents or output stream or any previous contents or appended text. So the answer is fopen of null will flush the output streams. Similarly, you can also write fflush of stdin whenever you have any difficulty in reading the content from the standard input devices. Similarly, you can also write fflush of stdout whenever the output is not displayed properly to the standard output device. You can also write fflush of stderror if you have difficulty in displaying the error messages to the standard output device. If you are writing simply fflush of null, then it will flush or clear all the output streams. So it is a Very useful function. Now next question is dash remove. Which function removes the named file so that a subsequent attempt to open it will fail? That means which function is used to remove a file from your system so that next time when you will try to open that file, you will get error. So the beautiful remove function is used. So remove function is having only, it takes only one argument. So the option A is correct. That remove function takes the address of the file which you want to remove. So remove constant star file name is the correct answer. Next question is related to EOF. EOF is an integer type defined in stdio.h. It is a macro and it has a value of dash. Whether it has a value 0 or 1 or null or -1. So the correct answer for this is -1. That means when EOF is returned, end of the file is reached, then it returns -1. Then next question is regarding the first and second argument of fopen function. Now in the first and second argument of file opening is always a character string containing the name of the file and the second argument is the mode always. So the option A is correct. Okay. The option B is given a character string containing the name of the user and the second argument is mode is not correct. It is incorrect. Similarly, a character string containing the file pointer and the second argument is the mode. Okay, that is also not correct and none of the above. So you can check it out. The correct option is option A. Now, next question is related to binary files. For binary files, a dash must be appended to the mode string. So, if you will append a character B, then the mode becomes binary. So, the options are nothing, B, binary and 0, 1. So, the correct answer is B over here. Now, the next question is related to ftell function. The ftell function is doing what? It takes the file pointer to the end of the file? No. Because end of the file, you can take the file pointer to the end of the file using either rewind, using either fseek function. Then it takes the file pointer to the beginning. No, that is done by rewind function. Takes the file pointer to the current position. No, that is also done through fseek function and gives the current position of the file pointer. That is the correct answer. So the answer to this question is D. Now, after understanding a number of questions related to file handling, let us go and run some programs related to random access to file using fseek, ftell and rewind. Let us move to our dev C++ compile. Now, how to do random access to the file, and for this we will demonstrate that how to write a program to store the alphabets into a file and will display the alphabets and their corresponding integers to a file, that is your standard output device, and we will make use of fseek, ftell and rewind functions. Now, let us start with the program. So, let me take one integer variable in type, then one character variable to read character by character from the file, and one file pointer let us declare, so which is nothing but fp. So, first thing is we need to open a file and we have to store the characters. So, fp is equal to, we will use the function fopen and write down one function name alphabets dot txt, this file, and first time we are creating this file, so use the mode w. Then check the file gets opened successfully or not. If fp not equals to null, then the file opened successfully. Write down the message, file opened successfully. And you can do your operations. Otherwise, we can simply write that printf unable to open the file. Due to some reason, the file could not be opened, unable to open the file. And you can simply return from here. Then what we will do? Next, we will first write down the characters to the file. So let us write printf writing characters or alphabets to the file. We have put the message, and how to write down the alphabets? Let us write down a loop. So if char is equal to character A, okay, then character less than is equal to up to character Z, and then do CH plus plus. Then how to write down these characters? We will write F put C, CH, comma, your FP. To our file, we are writing this loop, and one by one characters will be written to the file. Now, after doing our file operation, so let us write down a message that alphabets written successfully to the file, and close your file once your operation is done. Now, let us run this program and check. Now you can see here that file opened successfully you are getting. That means you have given a valid address it is giving you. Then the writing alphabets to the file, or okay, and then the file alphabets written successfully to the file is given. Now after this, let us check whether the file has been after that let us check the file contents. So let me go to check my file. So in my documents, the alphabets.txt file I can find over here. Now you can see here that the file is already containing. Now the characters are written successfully, or the alphabets are written successfully to this file. So once check it physically whether the alphabets are correctly written to the file or not. Okay. Now let us move back to our program again. So let me comment this messages. Okay. And we'll move to the next part of our program. So I want to display those alphabets on my screen. So first of all, write down a message printf display your numbers and alphabets. Okay. So how will I do that? First of all, let me write down the numbers or display the numbers on the screen. So for that, I'll take I is equal to 1, for there are 26 alphabets are there. So I less than is equal to or less than 27, or you can write less than is equal to 26, and then I plus plus. Then write printf. Okay. Printf percentile d percentile d, comma, print the value of I. Now let us check once whether the numbers are coming properly or not. So if you want, you can give a space over here. So you can see over here all the 26 alphabets are coming on the screen. Okay. So let me continue with this program. Now let us display the alphabets. For displaying the alphabets, let me give one new line character over here. Again write down a loop. So for I is equal to 65, I can take the ASCII values to display. Less than is equal to 90, and then I plus plus. Now how to display the alphabets? So for that, for displaying the alphabets, I have to write give my percentile C for displaying the alphabets, comma I. Okay. Now let me check how the alphabets are looking on the screen. You can see over here all the alphabets are now jumbled. Okay, jumbled in the sense there is no proper spacing. So if you want, you can give a space over here, and you can see that it is somehow looking better. So if you want, you can give one more space. So with double spacing, how it looks. Yes. So now alphabets are displayed on the screen properly. Now you can check by giving one more space in the numbers also. Yes. Somehow it is looking perfectly. Now let us do random accessing to the file. So write on printf what is the current file pointer position. So for finding the current file pointer position, let us open the file again. So let me write printf/n. Again open the file in read mode. So fp is equal to fopen. So what is the file name? Our file name is alphabets.txt, and this time you have to open the file in read. Same thing you can check if the file is not opened successfully, if fp, or let us copy paste the same message. So you can copy paste these lines. Same checking we are doing. So paste it. Okay. Now file is opened successfully or not, you have checked. Now let us check what is the current file pointer position. So how to check? Using ftell function you have to check. So current file pointer position, that will be given by percentile LD, because ftell function returns a long integer. So let us write ftell of fp. ftell of fp. Okay. Now the same thing you can also do using fseek by writing fp, 0, 0. That means with 0 displacement and from the beginning of the file, then you take you keep the file pointer at the 0th character. By default it does that. So then read that character which is there at the first place. So you do fgetc or just getc from the file, and then print the character. So we'll write printf percentile C or first character or first alphabet. So percentile C, comma ch. Now after getting the first character, then where will be the file pointer? So again we will copy paste this message and we will print it over here to check the after displaying the first character whether the file pointer automatically moves to the next character or not. That you can verify over here. Now let us run this program. So you can see over here that there is a mistake over here regarding this. We will remove this and run it again. Now you can see here, after the file opened successfully, the current file pointer position is 0 and the first character is A, and the current file pointer position now advanced to 1. So to see the output properly, let us use /n properly. So I can use here one more /n and check the output again. So you can see here current file pointer position is 0, first character is A. After that it is automatically moved to the first character. Now again use the same operations fseek and this. So let me copy paste this. So now I want to move to the fifth character. Okay. Now what is the fifth character? Or let me write here 4 so that this becomes fifth. And what is the current file pointer position? Let us check this. Now you can see here, the last time the current file pointer position was at 1. Now we have moved to the fifth character. So the fifth character is E and the current file pointer position it is 5 because we are counting from 0 and we have written the displacement value of 4. So now the current file pointer position is at fifth character. Similarly, from the beginning, if you want to move your file pointer position to any location, suppose I want to take my file pointer position to the last character. So I'll write here the displacement is 25 from 0. So I will see the last character and what is the current file pointer position. So always in this case, what I am trying to do over here, that fseek is taking the origin of the file. From the origin of the file pointer, I am writing down the displacement. So that you have to keep in mind. But again, we will try not from the current file pointer position or not from the origin. We can also take the current file pointer position and write down the displacement values. So first let us check that whether we have reached to the end of the file or not. So you can see over here, earlier the file pointer was at the fifth character. Now the last character is displayed as Z and the current file pointer position is at 26. That means we have reached to the end of the file. Now, after reaching to the end of the file, if you want to move to the beginning of the file, we can simply use the rewind function. So, by writing rewind of fp, we can go to the beginning of the file. So, again check what is the current file pointer position and run it and see. Now you can see that after applying rewind, the current file pointer position has reached to the beginning of the file again. Now let us use fseek in another way. Suppose I would like to write like this. So let me use the same logic over here. So initially, now after rewind function, my current file pointer position is at the beginning. Now let me move to the ninth character. So it is going to display me the 10th character. So let us check what is the 10th character. Okay. So the 10th character is like this. So from the beginning of the file, the 10th character is J and the current file pointer position is at 10th character because you have done the displacement of 9. Now, after doing this, let us move to the 15th character from the current position. So, what do we have to write? We have to write fseek of fp, comma. From the current position we have to write. So, I want to move by 5 bytes. So, I can write 5, comma 1. And check the current file pointer position. So again, copy this line, current file pointer position, you have to check. Now, which is that character? If you want to check, you can write this. So, earlier it was at the 10th character, now we have reached to the 15th character. So, we can change this to 15th character. Okay, now let us check. Now, earlier it was at 10th character, the 15th character is P and the current file pointer position is at 16th now. So, this way we can use the fseek function. Suppose you want to go to the end of the file also, we can directly write fseek 0 or file pointer, comma 0, comma 2. Okay. and let us check the file pointer position and run this and see. So you can see that from the current file pointer position was at 16th, now it has reached to the end of the file. So this is the uses of your fseek function, and it is the most needed function whenever you want to randomly position the file pointer at anywhere inside the file. And ftell will help you to know the current location of the file, and rewind will help you to quickly rewind it, that is from the go to the beginning of the file. Okay, now next we will try to understand another program related to file handling. Now in this program we are going to read the content of a file and display it on the screen. So reading the content of the file, here we are going to take the same C file and we want to show it or display it on the screen. So let us write hash include stdio.h int main and return 0. This is the structure of the file. Let us deal with a file. So create a file pointer. So file star fp. Take a character variable because I want to read character by character. First you need to open the file. So fp is equal to fopen. First the name of the file we need. Now as we need the name of the file and I am going to use the current file, so let us first save it. So let me give this file is file2.c. So you have to give file2.c. And this file we are writing. So this file we will open it in which mode? We will open it in read. Now if fp, so what we will do first? First we will write the content and then we can open. Otherwise if fp double equals to null, then printf file opening problem and then write and then return from here. So if you are successfully able to write the content to the file, then how will you read the content? Okay, let us write while. For reading the contents you can use fur function till the end of the file. Not equals to end of the file, I should do the reading and writing process. So ch is equal to fgetc of fp, get a character from the file, and then fputc, put that character onto the screen. So ch comma fp. So this read and write process should be continuously done till you reach to the end of the file. So this is the way. Then we have to close the file fclose of fp. Now let us run this program and see the output. So you didn't get anything on the screen. So why? So what is the error that you are not able to get any output? So what you have to do here, first that file should contain the contents, then you should open it again. So the mistake what we have done over here is open the file in write mode first. Okay, then you write down the contents to that file and then you open the file again into the read mode. So what we will do now? So fclose of fp So let us take any ordinary file, any text file let us take. Okay. Let us write sample.txt. And let us do some writing to this file. So how will you do the writing? The file is opened in write mode. So printf enter some text and for, so here we can write down the for loop, okay, or we can write down while the ch not equals to, suppose let's take dot or period symbol, you should read it out. Okay, now ch is equal to get the characters from the standard input device, and fseek put it to the file ch comma f. This process would be continuously done. Then we should close our file. So f close up fp. Then open the file again in read mode. So fp is equal to f open. The file name is sample.txt. And open this file in read mode. After opening this file, then read the content and display it. Now let us check it. Okay, enter some text. This is my sample file. Contains few lines of text. Some lines I have written, and I am putting a period symbol or dot because I have written the logic that when the character is equal to dot, then not equals to dot it will read and then it will stop. So what is the reason for? Let us check. If ch not equals to that dot, then it should read. Okay. Now let us understand how to read some lines of text and write to the file, and then open the file in read mode and then display it. So for that reason, we have taken a sample.txt and we have opened it in write mode. Then we want to write down continuously the characters to the file. So we have written the logic while the ch is not equals to dot. That means until you will put a full stop or dot character, then it should read those characters and write it to the file, and then we have closed the file. After closing the file, as we want to display the content of the file, open the file in read mode and till you reach to the end of the file, while not end of the file, you read those characters and display it on the screen. So now let us check how to see the output of this. Okay, now suppose I am writing this is a sample line and put the dot. That is the stopping criteria. So you can see here it is written to that file and again it is displayed back on the screen. So this way file handling programs can be written. Now let us go back to our slides. In this video we have understood that how to deal with a file, what are the various file opening modes, how to do random accessing with a file using fseek, ftell and your rewind function, followed by we understood how to read data to a file and display data from the file. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.